Okay, we're going to give you some more critical value examples, and we'll talk about the closed interval theorem after we find critical values. So here's some additional examples. We got f of x is x plus 1 over x squared plus x plus 1. So we're going to look for these critical values, meaning we have to take the derivative and set it equal to 0. So we have quotient rule for this derivative here. Okay, so let's find out what we get by quotient rule. This derivative is 1, and here we get 2x plus 1. F prime x will be x squared plus x plus 1 minus x plus 1 times 2x plus 1, everything over x squared plus x plus 1 squared. Now, on top here, you're going to have to use FOIL. So we have x squared plus x plus 1 minus 2x squared plus x plus 2x plus 1, everything over x squared plus x plus 1 squared. So we're going to simplify a bit here. And that's going to be minus 3x if we combine like terms. And then this is over x squared plus x plus 1 squared. So let's see what we get here. Minus x squared minus 2x. All right, let me double check. Yeah, it looks like this is what we get. So I'm going to factor out that negative 1. So we're going to get f prime x going to be negative x squared plus 2x over x squared plus x plus 1 squared here. So here's our derivative. And this is what we need if we're going to find critical values. Now remember, if you're going to find a critical value, you're going to need to know where that derivative is 0 or where that derivative does not exist. So you're going to do two things here. You're going to set the numerator, include the negative sign, bring it up with you. You're going to set that equal to 0 in one case, right? And then I'm going to say, look at the denominator. You're going to set the denominator equal to 0. Because that's going to tell you where that derivative does not exist. So we got this numerator equal to 0, and we got the denominator equal to 0. Okay, so we're going to have to solve two equations here. So this means I have x squared plus 2x equals 0. I can factor, right? I can actually divide both sides by that negative 1 here. So sometimes people say, what'd you do with that negative 1? Well, divide both sides by it, I guess. And you're going to end up with x is 0, x plus 2 is 0, or x is negative 2. So these are two critical values. Go back and double check here. They're in the domain, and I want you guys to double check something here. Remember this domain down here, right? The domain of the function. Right? It's all values except where the denominator is 0. Now, I get the feeling x squared plus x plus 1 will never be 0. And we can find out if the discriminant is, if we use a quadratic formula, because we can't solve this by factoring. So remember this discriminant, b squared minus 4ac. If that's negative, well, then this denominator is never 0. So my b value is 1, so this is 1 squared minus 4 times 1 times 1, which is in fact negative 3. So it is negative. So that denominator, sure enough, is never 0. So all real numbers is in the domain. So when x is 0 and negative 2, you do have points on the curve. So these are critical values, so you guys know. This portion here, the next equation, when you try to solve this, right, this implies that x squared plus x plus 1 equals 0. And again, this never happens, so there's no solution here. So the only two critical values here are going to be at 0 and negative 2. And that's how we find critical values. All right, so let's look at another. F of x is the square root of x, 1 minus x. And I'm going to do the following. I'm just going to distribute. So I got the square root of x minus x squared of x, which really is x to the 1/2 minus x to the 3/2. So here's my function. So remember what we need to do to get critical values. Right? I'm going to set that derivative equal to 0, or find where that derivative does not exist. The domain here is all real values, or I should say all numbers greater than or equal to 0. So here's my derivative. F prime x becomes the derivative of the difference. Okay, so let's double check here. 2, this is going to be 2 over 2. Is that right? Double check. So that's positive 1/2. All right. And just like we discussed earlier today, we want to factor here, ladies and gentlemen. We want to factor out the greatest common factor. So we're going to factor that 1/2 x to the, now here's what you're going to have to think about, right? You got negative 1/2, you got positive 1/2. You want the smallest power. That's going to be your GCF. Right? So we're looking for the GCF. So the smaller power here is going to be, negative 1/2. But don't forget, I got to multiply it to the quotient. And your quotient is found by taking the expression you have to begin with and dividing it by the GCF. Okay, so this is how we get the quotient here. And our GCF is down here. So what happens now is going to be 1/2 x to the minus 1/2 minus 3/2 x to the 1/2. They're both 1/2 x to the minus 1/2. And this cancels. So we got 1 minus, and this is now properties of exponents, but if you look at 3/2 divided by 1/2, that's going to be 3. And then this is x to the 1/2 minus a negative 1/2. So you end up with 1 minus that 3x to the 1/2 plus 1/2, or really the quotient is 1 minus 3x. So this goes up here. This is the quotient. This is replacing that q. Let me try to tighten this up here. Okay. So this will be 1 minus 3x, and this is my derivative. We're going to say, let's copy this here. Let me try to copy it. Don't know what's going on with this I whatever. This I. Okay, whatever, I'll write it down. F prime x is, this is going to be now 1 minus 3x over, you got 1/2 x to the minus 1/2, so that's 2x to the positive 1/2, ladies and gentlemen. And this derivative is 1 minus 3x over 2 square root of x. Okay. Now, remember, for a critical value, we need, I guess we're using gray. We need to set the derivative equal to 0. So this is 1 minus 3x over 2 square root of x. That has to equal 0. Which really means, to get that derivative to be 0, it means my numerator is 0. And remember, this derivative also has to be, undefined, or we should say this is going to be, it does not exist, right? So that will happen when the denominator, so go back over here. That's when that denominator is 0. So we're going to say 2 square root of x is 0. So this is going to give me my critical values, right? For critical value. So we solve this for x. X is going to be 1/3. And this means the square root of x is actually 0 if I divide both sides by 2, right? And this really means x is 0. So I have two critical values. One at 1/3, and then the other at 0. These are my critical values. All right. Another example. F of x is 4x minus tangent x. So we need to differentiate the function. And here we go. Derivative of 4x is 4. Derivative of tangent, secant squared. F prime x is 4 minus secant squared. Now remember, we got to set this equal to 0. And what this does for us is we get 4 minus secant squared x is 0, or secant squared x, we could do it this way. Let's say secant squared x equals 4. Okay, because I can add secant squared to both sides. And this means secant will be plus or minus the square root of 4, or secant will be plus or minus 2. We're going to use the square root formula. Now, secant is the reciprocal of cosine. So we have 1 over cosine is plus or minus 2. And solving for cosine now, cosine's plus or minus 1/2. So that means two things. It means cosine is positive 1/2, and it means cosine is negative 1/2. So we got two trig equations. Okay, so there's two trig equations to solve here. And what I'll say here for the first trig equation, let's solve the first one. And how you actually do that is, the cosine's positive, so this is going to be your reference angle. And the definition of cosine is going to be adjacent over hypotenuse. So here's x. And my adjacent side, adjacent means next to, 1, 2. And what you guys will recognize is this will be the square root of 3. And more importantly, the special triangle you're talking about, this means x will be, looks like it's 60 degrees, or pi over 3. Now, this is my reference angle. And if we go and we say all students take calculus here, right? Let's going to get every solution because they didn't restrict my domain here. This is an unrestricted domain. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, all students take calculus. So what this means is here's my first angle, pi over 3. And here's that second angle, pi over 3. This is where cosine's positive, right? So all students means, and then takes calculus, quadrant 1, quadrant 4, cosine's positive. So my first solution we found for positive cosine was pi over 3. And I'm going to say my second solution here is 2 pi minus that pi over 3. And yes, that'll be 6 pi over 3 minus pi over 3, or the second solution will be 5 pi over 3. Okay, so we're looking at these two solutions here. And that happens for positive cosine. So this is where we're looking at. Cosine's positive. And then you say, what about the others? Well, you also have cosine here being negative 1/2. So you say, what quadrant is cosine negative? Excuse me. Quadrant 2 and quadrant 3. So here's this reference angle, which means that my third solution will be pi minus pi over 3. Or the third solution is, we see that as 3 pi over 3. It's going to be 2 pi over 3. And then similarly for the fourth solution, because cosine's negative in quadrant 3, that's going to be pi plus pi over 3, which is 3 pi over 3. So the next solution is going to be 4 pi over 3. And so these are the solutions here for cosine being plus or minus 1/2 here. Okay, because we have two solutions. And more importantly, what we can do is pick, typically we pick, since there's no restriction on the domain, you'll pick maybe two solutions. You're going to pick the first one, the quadrant 1 solution, and you can pick the quadrant 2 solution as well. Now, notice what I mean by that. Generally speaking, this is going to be the general solution. If I take x1 and I say, okay, the solution is pi over 3 plus n pi, what we're doing here is we're obtaining, if I rotate this x1 180 degrees, here's what I mean. We get this next solution here because it's in the opposite quadrant. And then similarly, what I'm going to do is I'm going to take this x3 solution and rotate this one 180 degrees, and we're going to get the opposite quadrant solution. So we're getting all the solutions here. And we're going to call that one x2 in general, even though that was what we called that initially x3. I think I lost my computer screen. We're getting it back. Anyway, that's 2 pi over 3 plus another n pi. So this is the general solution, ladies and gentlemen, for where you have that derivative equal to 0. So these are the critical values. It became a trig equation. And, you know, trig equations, ladies and gentlemen, are part of this course. Don't try to shy away from them, because I'll be giving you these kind of questions on your test and final, because trig is a prerequisite. You should be knowledgeable of trig. You should know the fundamentals. And here's the fundamentals for trigonometry. So here you go, ladies and gentlemen. Here's your critical values. Just want to say that. The CV. And there's infinitely many. N is an integer, right? N is in this set. So, yeah, go back and study your trig equations. I have videos on my website and on YouTube about how to solve these. Essentially, that's how you look at it. So we got pi over 3 plus n pi, and then 2 pi over 3 plus n pi, generally speaking, the general solution. There it is. So that brings us to a theorem that I wanted to get to today. The closed interval method. And this comes back to this theorem that we gave and talked about earlier. Let's see if I can find it here. Oh, weird. We want to be continuous over closed, bounded. It's essentially here, extreme value theorem. So you're looking at the extreme value theorem, and you require your function to be continuous over the interval AB. And then they say f will have an absolute max and f will have an absolute min. So here's the method that you're going to use here to actually find those values. They call that the closed interval method. So essentially, here's what they want you to notice or to do. Yes, you have to assume, or you have to have f being continuous over that interval AB. And so you know that you're going to have, an absolute max and an absolute min. So then there will be an absolute max and an absolute min. And this is going to be over this interval. They call it absolute because it's just over the world they're looking at is a very small world. It's over that interval AB, so they're calling it an absolute max over that interval and an absolute min. So we know we have an absolute max and an absolute min in that interval. So the question is here, we're going to say, here's the big question, right? How can we find it? And how you find it really is here's the procedure for how you find it. Find the values. You're going to say determine, I'm going to write it this way. Determine the critical values over that interval. If they are there in that interval, they're going to be. And 2, find the value of the function at the critical value. 3, find the value of the function at the end points. And you say, what are the endpoints? Right? The endpoints are going to be at A and be at these values. You're going to find the value of the function at the endpoints. And here's your conclusion. Here's what this really means. Once you've done that, I'm going to say here's the conclusion. The absolute max over the interval is the largest value in steps 1, 2, and 3. Really steps 2 and 3. It's the largest value. And the absolute min over that interval AB is the smallest value in steps 2 and 3. So for the absolute max, you're going to get the largest value. And for the absolute min, it's the smallest value. And it's a very simple idea. Here's what I mean by that, right? Let me draw a picture so you guys can understand how this really works. It's a simple thing. Remember, you have an interval AB. And your function can look a lot of ways over this interval. Okay, it's continuous. So in the interval, you can have these special points here. And this is where you have a critical value, by the way, because you have a horizontal tangent, right? Remember that? So there's a critical value in that interval. There's more than one critical value. So here's another critical value. And then you're checking the endpoints. And the reason it's not a critical value at this endpoint. So what I'm going to do is I'm going to get rid of that. And I'm going to paint it maybe dark blue. Okay. And then paint this one light blue. This is the value of the function at the endpoint. So we're going to have to find all of these values. I'm going to call this C1 and call that C2. So notice when we say absolute max and absolute min, those are the altitudes. So I can look at this picture and I'm going to say to you, you know what? I think that's a little bit, no, it's not better. Let's see if I could draw a straight line. Try to do what I did this morning. No, maybe that's better. Here's my C1. There's my critical value. And then I have another critical value. There's C2. So if I check these altitudes, I can say, oh, here's F of C1 and here's F of C2. The value at the endpoints here, this is F of A, and then up here would be F of B. Because we're looking at, like I said, these altitudes, F of these values. Now, the largest value in this picture, so you guys can see, this one's the max right here, F of B. So that's going to be our absolute max over that interval. And then over here is the smallest altitude. So that's your absolute min. So remember, their altitude values, the shortest altitude is the absolute min. The largest altitude is the absolute max. That just corresponds to Y values. So as you can see, it can happen at a critical value or it can happen at an endpoint. So this curve could look a lot of different ways. But that's the idea behind it. A nice continuous curve over a closed interval guarantees an absolute max, absolute min in the interval. So, for example, and they're going to say, determine the absolute max and min. And first example, they're going to give you a function and they have to give you an interval. So I'm just going to look in your book and say, let's find a function. How about this one? X to the fourth minus Well, I don't want to do, I think I usually give you guys, well, it doesn't matter. I don't know if you guys have solutions. Okay, I'm going to do a x cubed minus 6x squared plus 9x plus 2 over the interval -1 to 4. X cubed minus 6x squared plus 9x plus 2. So here is a function, and here's the interval that they're looking at. So find the critical values. So f prime of x is 3x squared minus 12x plus 9. You set that equal to 0. So 3x squared minus 12x plus 9 is 0. You can factor out a 3 or divide both sides by 3. And you get x squared minus 4x plus 3 equals 0, because you divided both sides by this number 3 here. And now you can factor. I love factoring, because you get to solve a quadratic by factoring. And so you get x minus 3 is 0, and x minus 1 is 0, which means x is 3 and x is 1. You solve those equations. And this is a polynomial, so the domain is all real numbers, ladies and gentlemen. So you found some critical values here, okay? 1 and 3. So, okay, you know about the critical values, but what about this interval here? The only critical value, I guess you have to use both of them. Yeah, 1 and 3 are in that interval. Yeah, okay. So here's the process. We have to find, let's do it in red. Let me write down the function again. All right, so f of x is x cubed minus 6x squared plus 9x plus 2. So what I need is f of 3. I got to find what that is. I need f of 1. So I got to plug these values in. And I need my endpoint values, which is f of -1. I'm going to change the color for the endpoints. I need f of -1, and I also need f of 4, because remember, my interval is -1 to 4. All right. And every one of these here is a y value. It's a coordinate value. And so we're going to actually find out what these are. You guys don't have, I can't show you the TI here. Because I'm recording a video, blah, 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 blah. But I can do, let's look for a calculator here. Desmos? No. I have a calculator. Let's try this one here. I know it's crude, but here's the idea. Right, there it is. So I'm going to have to plug in 3 here. So I want you guys to know. Here's 3. Plug in that 3. So this becomes 3 cubed minus 6 times 3 squared plus 9 times 3 plus 2. And then this will be plugging in 1 in. 1 cubed minus 6 times 1 squared plus 9 times 1 plus 2. Plug in these values. This is -1 cubed minus 6 times -1 squared plus 9 times -1 plus 2. And then for the 4, you get 4 cubed minus 6 times 4 squared plus 9 times 4 plus 2. And plug in those values. And use your calculator, ladies and gentlemen. I'm actually going to use the TI. I'm going to tell you what f of 3 is, so you guys can handle that on your own. And we have 3 raised to the 3rd power minus 6 times 3 squared plus 9 times 3 plus 2. And this value is 2. So f of 3 equals 2. So I have to look at all the values. Now let's try 1 cubed. So we have 1 to the third power. Let's get out of there. Minus 6 times 1 squared plus 9 times 1 plus that 2. And you get a 6. And then you get negative 1 raised to the third power minus 6 times negative 1. I think we're going to have to raise that to the second power, right? Ah, clear. Limited space. I got to try it, start all over here. Okay. It's actually easier if I do it in my head. You guys know that. It's kind of crazy, but all right. I just hit clear. Negative 1 raised to the third power minus 6 times that negative 1. All right. How about if I do this? I'm going to do this here for you guys. Arithmetic is a lot easier to do. It's negative 1 minus 6 times 1 plus negative 9 plus 2. Negative 1 minus 6 minus 9 plus 2. So that's negative 16. That's going to be a negative 14. Double check my arithmetic. Okay, and then this is 64 minus 6 times 16. 9 times 4, 9 times 2 is 18. That's 36 plus 2. And then 64 minus 96 plus 36 plus 2. So here's what you end up with. 64 minus 96 plus 36 plus your 2, and you get 6. Okay. So here's the process, right? You have to find the smallest value. Here's the smallest value. This is your absolute minimum value here. That's the smallest. And the largest is here. So you have a 6. We have a 6. And that's your absolute max. So you got absolute max here, here with an absolute min here. And that's your procedure. Okay, so you just find the critical value and critical values in this case, 2 of them, and then you find the values of the function, the altitudes, but include the endpoint. I'm going to try another here for you guys, see what you think. F of x here. I'm going to put x squared minus 1 cubed over an interval negative 1 to 2. So again, remember we need that derivative here. So differentiate 3 x squared minus 1 squared times by chain rule. Derivative of x squared minus 1. Chain rule. And that's 2x. F prime x becomes 6x times x squared minus 1 squared. So we set that derivative equal to 0, which means we have 6x x squared minus 1 squared equal to 0. Okay, you're going to have to set each term equal to 0 by using that 0 product rule. And solve for x. That means x is 0, right? Whenever you have anything here raised to the second power and it equals 0, that means whatever was under the radical, I'm sorry, not radical, whatever your base is, this is the base. X squared minus 1, that must be 0. So you're saying this thing has to be 0 because 0 squared is 0. And now you got two ways to solve this one, right? This means x squared is 1 by the square root formula, x is plus or minus square root of 1, or simply x is plus or minus 1. So the interval they're talking about is -1 to 2. So when they say -1 to 2, that means, ladies and gentlemen, 0 is in that interval, so is plus or minus 1. So I have 3 critical values here over the interval. I have to check. Let's go back to the function here. F of x was x squared minus 1 cubed. So let's see what we have to check. Don't forget, you got to check the endpoints as well. Right? So in red, I'm going to put the critical values that we have to check. We have to find f of 0, f of -1, f of positive 1. And in blue, we have to find the value of the function at the endpoints. Well, one of the endpoint happens to be, I think that's what it is. One of the endpoint happens to be a critical value, right? So we have to check at the endpoint. So we got it. It's a critical value. We have it. And so you plug in these values. 0 squared minus 1 cubed, which is really -1 cubed, which is -1. -1 squared minus 1 cubed becomes 1 minus 1 cubed, which is 0. 1 squared minus 1 cubed is 0 cubed, which is 0. And then we get 2 squared minus 1 cubed is 4 minus 1 cubed. 3 cubed is 27. So, which is the largest value? Well, the largest value is 27, and that's your absolute max. The smallest value is -1, and that's your absolute min. So you answer the question here. You got absolute maxes and absolute mins. And so, yeah, ladies and gentlemen, there you go. That's the closed interval method. You got to check the value of the function at the critical values and at the endpoints. So maybe we'll try just one more for the road. And I'm going to try a nice one like this. Let's say f of x equals x minus 2 cosine x, and it's over -pi 2 pi. Okay? Trig functions. Let's find the derivative here. We got to find those critical values. So let's differentiate and set this equal to 0. That's going to be, well, let's use properties here. And if I really wanted to use, I'm going to pull out my 2. All right. Derivative of x is 1. Derivative of cosine is minus sine. So here's what we get. 1 plus 2 sine x. We got to set that equal to 0. So 1 plus 2 sine x is 0. Solving for sine, ladies and gentlemen, I get sine being -1/2. Just solving for sine. So I'm going to have to consider how to find solutions here in that interval they gave us, -pi to pi. Okay, so that's kind of like talking about, -pi to pi. Anyway, I'm going to look at the Cartesian coordinate. We have to consider, remember, every time you solve a trig equation, you have to find that reference angle. So you're going to look at the positive sign. And you got to use the definition again. Opposite over adjacent. So we draw a right triangle. where here's x opposite over adjacent, that's the square root of 3. So we get the same special triangle, but this is actually 30 degrees, which is pi over 6. Right? Pi over 6 here, pi over 6, this is an equilateral triangle. However, that's really not our solution. So remember from your trig course, hopefully you guys got nice and fat in trig. You guys know what I'm saying? We did a lot of problems in trig. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. All students take calculus. So even though my reference angle is a quadrant 1 angle, that's what a reference angle is. The question here was really negative 1/2. So we have to find the quadrants where sine is negative. Sine is negative in quadrant 3 and in quadrant 4. So here's two solutions here. Where this reference angle that we found, this, right, pi over 6 goes right here. Here's pi over 6. And here's pi over 6, because these are the quadrants where sine is actually negative. So let's find our first solution here. So x1 is going to be pi plus that pi over 6, or we say x1 is going to be 7 pi over 6. Okay? This is my first solution right here. The second solution for x2, the quadrant 4 solution, is going to be 2 pi minus pi over 6, or x2 is actually going to be 11 pi over 6. Okay, however, ladies and gentlemen, these are my solutions if my interval is 0 to 2 pi. The problem is they want solutions in this interval. I'm going to paint it red. Negative pi to pi. All right. And so we're going to have to consider that interval. So negative pi to pi, we have to find the coterminal angles. Coterminal angles are rays that share the same, terminal side there, I guess. Okay, that's what it is, the definition. Going back to trig. So negative pi, it's like saying, okay, I want you to start at negative pi. And you go, well, where's negative pi at? Negative pi is this line right here. And we have to rotate that. Let's think about that. Yeah, negative pi all the way up to positive pi. So we're rotating it this way. Yeah, let's not use the highlighter. Okay, so you're starting here and you're rotating 360 degrees. So we need to find a coterminal angle. This x1 is good. You say, why is that good? Because look at the factors here. Here's how I see this. Let me double check. This is negative 1. Oh, I think it might not be good. It's a positive 1 pi, okay? It's not good. So I need a solution that's from negative pi to positive pi. My x1 is 7 pi over 6. That's bigger. 7 pi over 6 is outside that interval, right? So if you said to me, I'm looking at the real number line, your solutions need to be between negative pi and positive pi. They have to be in this interval. So 7 pi over 6 is outside, and sure enough, so is 11 pi over 6. So you say, how do I find the coterminal solutions? Subtract pi. I'm sorry. Take that back. Take that back. We don't subtract pi. Let's take a look at this again in detail. You see, this gray solution, the general solution to what you see here is we have to add a multiple of 2n pi. And we have to add a multiple of 2n pi for this second solution as well. So x1 in general, right, is 7 pi over 6 plus 2n pi, and x2 is going to be, what's the other one? 11 pi over 6, okay? Plus 2n pi. So if n is 0, n is 1, that's increasing. I'm going to say let n be -1. N is an integer. This is the general solution. We get every solution. We get particular solutions by changing the values of n. So x1 will be 7 pi over 6 minus 2 pi. And I can do some arithmetic now. Multiply by 6, divide by 6. Let's see what we get. So x1 is 7 pi over 6 minus 12 pi over 6. And x1 will be minus 5 pi over 6. That is in the interval over here, by the way. -5 pi over 6. So we're there. Similarly, the second solution will be 11 pi over 6 minus 2 pi. Now, remember how we actually add these? 6 over 6? So the second solution will be 11 pi over 6 minus 12 pi over 6, which is -pi over 6. So x2 is negative pi over 6, and that's also in here as well. So I mean 0 is in the middle, so that -pi over 6 would be just to the left, I guess. So you found solutions, these critical values in that particular interval. Okay, there's work when you do trig, ladies and gentlemen. And then you say, okay, well, how do I deal with this again? Remember, let's go back to the equation here. Maybe I can copy it, right? And I know my interval, -pi to +pi. So once again, here's the value of the function. We need to find, by following that procedure here, in red for the critical values, f of -5 pi over 6 gets plugged into the equation. -5 pi over 6, or I should say the function, minus 2 cosine -5 pi over 6. The second one is f of -pi over 6, which would be -pi over 6 minus 2 cosine -pi over 6. And we might need to use some more space. Now the endpoint's in blue. F of -pi, plug that in. -pi minus 2 cosine of -pi. And then down here, f of pi is pi minus 2 cosine of pi. So remember, we have to find the value of the function at its critical values. These are the critical values that you just found in the interval. And then the value of the function at the endpoint. And whatever is the largest or the smallest. Okay, so I just want to remark to people here that f of -5 pi over 6, I'm going to clean this up a little bit. Okay, I'm going to use the fact that cosine is an even function. So that's minus 2. Let me think. Yeah, even. That means I could just take minus 2, 5 pi over 6. And then over here, same thing. So f of -pi over 6 is actually -pi over 6 minus 2 cosine of pi over 6. And then over here, f of -pi will be -pi minus 2, just cosine of pi, because cosine is even. And f of pi is pi minus 2 cosine of pi. All right, so cosine of pi, ladies and gentlemen, just to clean this up even more, right? You guys remember what cosine of pi is? Let me think of the curve. Isn't that -1? Double check. So that's -1. That's -1. And let's be careful. Pi over 6. So cosine of pi, right? 180. Yeah. All right. So let's get the others here. So to remind you here, cosine of 30 degrees, right, or cosine of pi divided by 6. If you guys remember what that is, what is cosine of pi over 6? Cosine 30 degrees here. So we're going to clean some of this up. Right? Isn't that the square root of 3 over 2? Yeah, so let me do this. Square root of 3 over 2. And then cosine of 5 pi over 6. Right? Cosine of 5 pi divided by 6. What do we get now? Negative. So we get negative 5 pi over 6 plus, that'll be plus square root of 3. So I want you guys to be careful here. All right, let me highlight it or something. I did some arithmetic. Over here, minus pi over 6, and that's minus the square root of 3. Okay, and that will be f of negative pi over 6. And here, f of pi, where are we at? Oh, okay. Negative pi plus 2. And this is positive pi plus 2. So here's my f of pi. So we need to find all of these values and the maximum and minimum of such values. Okay. Pi, ladies and gentlemen, do you guys know what's pi approximately? 3.14. So I'm going to use a calculator here to punch this in, okay? And I'm going to approximate to the nearest thousands. So I get negative 5 pi divided by 6. Okay, and I have to add the square root of 3. So this is going to be here, right up here. Negative 0.886. And then now I take negative pi divided by 6, and then I'm going to subtract the square root of 3 again. I get negative, ladies and gentlemen, 2.256. Okay, and then finally, negative pi. We're going to add the 2. So I get negative, and I'm going to paint that blue, 1.14. And then we have pi, right? We're going to get pi plus 2. I think that's going to be the largest value. 5.141. So it's safe to say this is the largest. You have the absolute max. The smallest is here, negative 2.2. Here's your absolute min. And it happens at x is negative pi over 6. And the absolute max happens at the endpoint x is pi. So ladies and gentlemen, here's your answers And, here's another illustration of all the details that you have to do for the closed interval method. And fantastic question, fantastic topic. So look these over and, have a good evening.